world that at first appeared boundless, early humans faced an innate challenge: how to make sense of their surroundings. The dawn of measurement was not born from a desire for precision, but from a fundamental need to understand relationships between things: the height of a tree, the length of a day, the weight of a stone. This quest began in the shadows of the Stone Age, when early people relied on their bodies as the first tools of measurement. A handspan, a foot, a stride, these simple yet vital reference points served as guides through vast landscapes. Just as an artist uses a brush or a musician tunes an instrument, early humans used their own dimensions to navigate and quantify the world around them. It wasn't long before they discovered the intrinsic rhythm of nature that governed their lives. The seasons, the lunar cycles, and the phases of the tides became not mere observations, but measures of time and distance. Over generations, these patterns morphed into more structured units. While one tribe might measure a distance in terms of a day's walk, another might describe the same space as 3 sunrises. These early systems of measurement served as connectors, intertwining daily life with the environment and fostering communal identities. As humanity evolved from nomadic tribes to settled communities, the need for more consistent methods emerged. The transition to agriculture required new forms of quantification. Harvests had to be counted, livestock tracked, and trade organized. The impulse to measure transformed from casual observation into a tool for survival and commerce. As civilizations arose, so did the sophistication of measurement. Ancient Egyptians wielded remarkable ingenuity, employing the foot as a standard unit while constructing the pyramids. The Greeks, in their quest for knowledge, began to explore geometry, recognizing inherent relationships within the natural world. An ancient Greek philosopher, Pythagoras, famously declared that all is number. This assertion set the stage for mathematics to intertwine with the fabric of measurement, leading to advancements that would influence the very way humans interact with their environment. In parallel, astronomy flourished as a discipline that blended measurement with the vastness of the cosmos. Ancient cultures developed precise astronomical calendars to predict seasonal changes and guide agricultural practices. The Babylonians, for instance, divided the day into 12 hours of day and night long before the invention of mechanical clocks. This cosmic dance of celestial bodies showcased a new understanding, elevating measurement from practical needs to a philosophical marvel. Humans were no longer merely measuring the Earth. They were attempting to plot their place in the universe itself. Fueled by a desire for accuracy and consistency, early trading societies began to standardize measurements, laying the groundwork for modern systems. The establishment of specific weights and measures was crucial for commerce to thrive, facilitating trade between disparate regions. For instance, the introduction of the bronze or silver shekel in Mesopotamia provided a uniform currency, a benchmark that allowed merchants to navigate growing marketplaces without chaos. This early drive towards standardization signified a profound shift in human interaction with the world, a move from localized, community-based systems to a broader, interconnected framework for understanding. Yet, this was just the beginning of humanity's journey through measurement, a journey that would continue to evolve through the ages. With the foundations now firmly laid, the stage was set for further advancements in tools and techniques that would forever change our relationship with numbers and the natural world. In the earliest days of human civilization, the quest to understand the world was inseparable from the first attempts at measurement. To quantify the vastness of nature, early humans turned to their surroundings, interpreting experiences in tangible terms. They relied on their bodies, using their hands, feet, and eyes as rudimentary measuring tools. A footstep became a foot, an arm's length became a yard, and the time it took for the sun to rise and set marked the passing of a day. These initial metrics were rooted in the physical and experiential, immediate and personal, forging the foundation for a complex system of measurement that would evolve over millennia. As societies grew and interactions among different groups intensified, the need for more precise tools became apparent. The first formal measuring instruments emerged as simple yet transformative innovations. The earliest known tool was probably the tally stick, where notches carved into wood or bone recorded quantities, offering a visual representation of numerical value. In ancient Egypt, the Nilometer, a calibrated stone structure, measured the Nile's waters with remarkable precision, directly influencing agricultural practices by predicting seasonal floods. Using shadows cast by the sun, early sundials offered a means to delineate time, anchoring daily activities and rituals in a predictable rhythm. These tools laid the groundwork for more sophisticated devices, such as the leveling instruments of ancient builders, which would ultimately elevate the artistry of architecture. By the time ancient civilizations such as the Babylonians and Greeks began to study measurement more rigorously, they transformed these rudimentary devices into sophisticated techniques. The Babylonians, who had a base 60 numbering system, related units of distance and area to celestial phenomena, reflecting their intricate knowledge of astronomy. They devised a system of degrees, dividing circles into 60 parts, a practice that resonates even in today's GPS technology. Meanwhile, the Greeks advanced measurement through geometric understanding. Mathematicians like Euclid synthesized knowledge on proportion and relationships among dimensions, laying the groundwork for more accurate calculations in both practical and theoretical realms. The cultural variations in measurement systems reflect not only practical needs, but also philosophical worldviews. While the Egyptians utilized specific units tied to the human body, the Chinese relied on a metric that entwined numerology with cosmological beliefs, emphasizing harmony and balance in their measurements. This diversity illustrates that measurement has always been deeply intertwined with culture, shaping not only how societies function, but also how they perceive their place within the universe. As humanity began to synthesize various measurement practices, the foundations were laid for a more unified understanding, setting the stage for advancements that would ripple through generations. As ancient societies continued to refine their tools and techniques, they inadvertently set the stage for a transformation that would change the very fabric of civilization itself. The evolution of measurement was no longer an isolated pursuit. It became a critical element in navigation, commerce, and scientific inquiry. Each new technique fed into the growing tapestry of human knowledge, driving curiosity and innovation. And as civilizations rose, the quest for greater precision and understanding of the world became a shared endeavor, acting as a catalyst that continued to push humanity forward into realms that were yet to be imagined. As humanity spread across diverse landscapes, each culture began to develop its own systems of measurement, shaped by the unique environment and needs of their communities. From the towering mountains of the Andes to the sprawling plains of the African savanna, these variations were not mere whims. They reflected deep connections between people and their surroundings. The practice of measuring was always about more than just numbers. It was an attempt to impose order on a chaotic world, to create a common language that could facilitate trade, navigation, and construction. Consider the ancient Egyptians who employed the concept of cubits, the length of a forearm from the elbow to the fingertips. This measurement was practical, grounded in the physicality of the human body. Cubits allowed the Egyptians to build the monumental pyramids, guiding their architects to create structures that stood the test of time. In contrast, the ancient Greeks, with their philosophical leanings, introduced more abstract measurements, leading to the development of geometry. Their approach allowed for precise calculations of distances and areas, transforming how people conceptualized space and shape. The Greeks sought not only to measure the world, but also to understand and explain its underlying principles, blending science with aesthetics. Across the vast expanse of the Pacific, the Polynesians navigated the open ocean with remarkable precision, employing an entirely different measurement system. They relied on the stars, ocean currents, and winds as their units of measure. Their knowledge of the natural world was so profound that it enabled them to traverse thousands of miles of open water without the aid of modern instruments. This reliance on celestial navigation illustrates a different kind of understanding, a measurement deeply entwined with the culture, spirituality, and identities of the people. Here, measurement was not merely a tool, but a way of life, forging connections between the heavens and the earth. In regions such as China, measurements were often defined by agricultural cycles. The Chinese system employed units derived from the dimensions of rice fields and the seasonal rhythm of planting and harvest. This interdependence fostered a communal understanding of measurement, an acknowledgement of the interconnectedness of society, environment, and time. Meanwhile, in Europe, the introduction of standardized systems during the medieval period aimed to facilitate trade and governance, leading to the eventual establishment of the inch, foot, and yard as units embraced by many Western cultures. Yet, this standardization clashed with local traditions and systems, highlighting the ongoing tension between the individual and the collective in the realm of measurement. As the cultures of the world collided through trade and exploration, these various systems began to influence one another, gradually leading to a convergence of ideas and practices. The early 18th century witnessed significant shifts as the Enlightenment sparked an emphasis on rational thought and the quest for universal truths. Measurements that had once been rooted deeply in local customs were challenged, leading to a movement toward a more unified approach. In this environment, the metric system emerged, an elegantly simple decimal-based system that would eventually be adopted by most nations, further reshaping the global landscape of measurement. The variations we see today reflect a rich tapestry of human experience, highlighting how different cultures engaged with the world around them. Each method of measurement tells a story, revealing how peoples adapted to their environments while striving to make sense of the vast cosmos. As we move forward in our exploration, we will delve into the rise of geometry, which brought a new dimension of understanding to measurement, uniting artistic expression with scientific inquiry in a way that would redefine humanity's pursuit of knowledge. As humanity navigated its environment, particularly in ancient civilizations, a profound transformation began: the birth of geometry. This sophisticated discipline emerged not merely as an abstract concept, but as a practical tool that expanded our understanding of space, shape, and relation. It was during this period that human beings began to formalize their observations about the natural world, establishing a systematic approach to measurement that would resonate through history. The origins of geometry can be traced back to early agricultural societies, where the need to divide land for cultivation led to the invention of basic geometric principles. Imagine a farmer plowing a rectangular field. The simplicity of squares and rectangles enabled an effective and efficient way to enhance productivity. Ancient Egyptians, in particular, refined these concepts. They devised a method to establish right angles using a length of rope knotted into 12 equal segments, creating the first known examples of practical geometry. As they raised monumental structures like the pyramids, these methods laid the groundwork for future explorers and architects who would continue to push boundaries. Across different cultures, geometry flourished, taking various forms that reflected local realities. The Greeks elevated this discipline to new heights, turning geometry into a rigorous mathematical system. Figures like Euclid and Pythagoras not only studied shapes, but also explored their properties through logical proofs. Euclid's Elements was not merely a compilation of geometric knowledge. It represented an intellectual framework through which theities of the mathematical universe could be systematically understood. The connection between different geometric figures began to establish a language of shapes and their relationships, something akin to learning a new dialect that spoke to the underlying principles of nature. As civilizations expanded and intellectual exchanges occurred, geometry intertwined with other fields, like astronomy. The measurement of land gave way to the measurement of stars, with geometry providing the critical tools to chart the heavens. The Greeks used geometric theories to map celestial movements, while the Babylonians developed intricate geometrical tables, paving the way for celestial navigation. This connection illustrates how the knowledge of geometry transcended terrestrial applications, highlighting the interplay between the earth and sky, and emphasizing humanity's desire to quantify and understand its existence on both fronts. This evolution of geometry from a practical tool to an area of profound intellectual exploration marked a pivotal moment in measurement history. By firmly establishing not just the concepts of shapes and spaces, but also their intrinsic connections, humanity unlocked a new realm of understanding. These foundational geometric principles not only served immediate practical needs for land division and construction, but also provided the underpinnings for future developments in various scientific fields. With this newfound knowledge, humanity was no longer just measuring the world, they were interpreting it, preparing for the seismic shifts that lay ahead in the realms of astronomy and beyond. The story of measurement was far from complete, yet this chapter in the rise of geometry set the stage for how we would come to quantify the cosmos. As ancient civilizations gazed into the vast expanse of the night sky, they encountered a celestial world not merely for wonder, but also as a guide to understanding their own existence and the rhythms of life on Earth. Astronomy became an early cornerstone of measurement, revealing patterns in the heavens that replaced mere observation with the beginnings of calculation. The movements of the sun, moon, and stars dictated agricultural seasons, navigation by land and sea, and even the timing of religious rituals. Temples and observatories acted as both places of worship and at times as the earliest laboratories where scribes meticulously recorded their observations, laying the groundwork for mathematical thought that would influence both timekeeping and distance. The early astronomers crafted sophisticated tools like the gnomon, a simple vertical stick used to cast shadows, from which they could derive the position of the sun. These shadows provided valuable insights into the passage of time, delineating hours and marking the solstices and equinoxes with precision. This merging of celestial observation with earthly timekeeping birthed the concept of hours and days as standardized measures. a notion that illustrated how humanity began to harness the universe to impose structure on their everyday lives. The shadow of a gnomon could thus be seen not only as a natural phenomenon, but also as a metaphor for humanity's desire to bring order to chaos. Cultures across the globe independently discovered the power of astronomy to shape their measurement systems. The Babylonians, with their base 60 numbering system, divided the day into 12 hours of daylight and 12 hours of darkness, a structure still reflected in our modern hours. In contrast, the ancient Egyptians meticulously crafted the earliest sundials, forming a direct connection between their agricultural practices and celestial cycles. At the same time, in the Americas, the Maya developed a complex calendar that interwove astronomical cycles with their agricultural calendar, giving them both a practical framework for planting and a rich tapestry of myth and meaning linked to the cosmos. As cultures encountered one another through trade, exploration, and conquest, their measurement systems influenced each other. The Greek philosophers contributed significantly by marrying geometry and astronomy, capturing the harmony of the universe in mathematical form. Ptolemy, a 2nd century astronomer, established a geocentric model where Earth was at the center of the universe. Though eventually debunked, this model still required precise astronomical observations and distances between celestial bodies, pushing the boundaries of measurement in ways that resonated through the ages. The culmination of these astronomical studies gave rise to a newfound appreciation for distance, leading to innovations like the astrolabe, which allowed navigators to determine their position on Earth by measuring the angle of celestial objects. Ultimately, the convergence of astronomy and measurement illuminated the intrinsic relationship humans shared with the cosmos. The act of gazing upward translated into a profound understanding of the rhythms that shaped their lives. As they charted the heavens, they also charted their own development, slowly assembling the pieces that would facilitate the standardization of measurements in the subsequent eras, a transformation that would connect disparate peoples and ideas into a cohesive framework for understanding the world. With this foundation laid, the path forward leads us to explore how these early concepts evolved into more systematic approaches to measurement, providing standardized tools that would change the fabric of society in ways yet to be fully realized. In the centuries that followed humanity's initial forays into measurement, the quest for consistency became paramount. Different regions and cultures created their own units, leading to a patchwork of measurements that often conflicted. A foot in one land might be shorter or longer than a foot in another, and the same could be said for nearly every unit of measure. This chaos hindered trade, diplomacy, and scientific inquiry. The need for standardization emerged as a unifying force, a way to bridge the gaps between diverse societies and create a shared language of measurement. The process of standardizing measurements was gradual and often fraught with conflict. The ancient Egyptians contributed significantly, utilizing the royal cubit, based on the pharaoh's forearm, as a primary unit for construction and land measurement. Conversely, the Romans expanded upon these ideas, implementing their own system, which included numerous local variations. It was not until the Middle Ages that a more structured approach began to take shape, particularly in Europe, where burgeoning trade routes called for common standards. This drew on previous systems, melding together aspects of Roman, Arabic, and local practices to craft a more unified approach. By the 17th and 18th centuries, the Age of Enlightenment catalyzed a cultural shift that prized reason and scientific inquiry. Thinkers such as Galileo and Newton laid the groundwork for a more systematic understanding of measurement, which demanded a corresponding system of units. However, the true turning point came with the French Revolution. In an era defined by calls for equality and rational governance, the metric system emerged as an embodiment of these ideals. Rooted in base 10 mathematics, the metric system provided a simple, logical framework that could be universally adopted, stripping away the complexities of local customs. Its adoption spread rapidly across Europe and eventually influenced global norms, forming an international standard. The implications of standardization extended far beyond mere convenience. It transformed commerce, science, and even daily life. With coherent units of measurement, trade could flourish on a global scale. Scientists could communicate findings without the barrier of conflicting measurements, paving the way for breakthroughs that would shape our understanding of the natural world. The consequences rippled through technology, agriculture, and industry as precision in measurement became synonymous with progress. Yet, the discussions surrounding measurement were not concluded. They only evolved. As the world approached the Industrial Revolution, the seeds of standardized measurement would soon yield a harvest of innovation and exploration, setting the stage for a radically new chapter in humanity's relationship with the physical world. It was in this fertile ground that the next wave of transformation began to take root, forever altering not just how we measure, but how we understand and interact with reality itself. The Industrial Revolution marked a watershed moment in humanity's relationship with measurement, acting as both a catalyst and a vehicle for unprecedented precision. As steam engines churned and factories sprang up like mushrooms after rain, the demand for uniformity and standardization became paramount. Gone were the days when a craftsman's judgment dictated dimensions. The rise of machinery demanded repeatability. It was an era that saw individuals no longer producing unique sculptures, but rather interchangeable parts designed to fit seamlessly into complex systems. For instance, the assembly of a steam engine or a textile loom relied heavily on the ability to measure accurately down to the millimeter, reshaping not just objects, but the very framework of industry itself. To enable this transformation, inventors and scientists, driven by necessity, devised new measuring tools and methodologies. The micrometer, for instance, emerged as a revolutionary instrument, allowing for minute measurements that were crucial in manufacturing. This new level of precision wasn't merely about fitting pieces together. It also paved the way for innovation. Think of the remarkable engineering of bridges and railways, where precise calculations had to account for forces of tension and pressure acting on materials. The rise of mechanical engineering epitomized the need for accuracy, fostering skills that would ultimately fuel the advancement of entire industries. Yet, alongside this technical progress was a profound cultural shift. Measurement began to be viewed through the lens of quantification, transforming the abstract into the tangible. As factories filled with machines operated on the tick of a clock, society also adjusted to a new rhythm, a time that dictated productivity and efficiency. Workers no longer engaged in the leisurely craft of artisanal production. They were part of an intricate clockwork mechanism where each second counted. The industrial landscape required not just labor, but also the rigorous application of numeric logic. Metrics became vital in discussions of profit and efficiency, altering attitudes towards labor and craftsmanship itself. In parallel, the Industrial Revolution nourished an increasingly intellectual culture, demanding that measurement intersect with scientific thought. Engineers strove not only to build, but to optimize, They calculated how to construct taller buildings or faster trains while ensuring public safety. It became clear that measurement was not merely an act of quantifying, but a vital component of human progress. The interaction of rigorous data with the real world fostered advances in fields ranging from chemistry to architecture, laying fertile ground for the innovations that would follow. This era forged a symbiotic relationship between industry and measurement, demonstrating that progress was as much a function of meticulous assessment as it was of raw creativity. As this symbiosis deepened, it set the stage for the next leap in human understanding, merging mathematical principles with the newly refined art of measurement. What began with simple tools and intuitive practices had blossomed into a complex web of scientific inquiry and industrial efficiency. The world, now measured in increasingly precise terms, beckoned for the next evolution in our quest to quantify the very essence of existence. Thus, as we stand at the cusp of this new era, a time when mathematics would soon become an inseparable partner to measurement, we embark on an exploration of how these two domains would combine to create an even more interconnected understanding of our world. As humanity's quest for understanding evolved, so too did the need for precision, a need that inevitably brought mathematics into the fold of measurement. At its core, measurement is more than just numbers. It is a bridge connecting abstract mathematical concepts with tangible reality. Early on, people relied on simple techniques, such as counting and comparing sizes. But as civilizations grew and their needs became more complex, so did their methods of measuring. Enter mathematics, the language that allowed for the codification of these ideas into something both universal and comprehensible. The shift from rudimentary measurement to a systematic mathematical approach revolutionized how humans interacted with their environment. Take, for instance, the way the ancient Egyptians built the pyramids. They didn't merely guess the proportions. They employed geometry to ensure angles aligned and dimensions matched. The way they expressed relationships, like the ratio of a pyramid's height to its base, was deeply mathematical. These ratios became foundational principles not only in architecture, but also in astronomy, agriculture, and various trades. Mathematics offered a consistent framework, allowing for more accurate and large-scale projects that transformed entire societies. As cultures began interacting and sharing their knowledge, particularly during the flourishing of ancient trade routes, measurements became standardized, thanks in large part to mathematical principles. The development of a universally understood measurement system resulted in significant advancements in navigation, science, and commerce. The Greeks contributed Euclidean geometry, which defined the accuracy of measurements, while Arabic mathematicians introduced advancements that built upon these concepts, basically layering ideas like a fine tapestry. This blending of mathematics and measurement underscored its importance in day-to-day life, creating a foundation for trade agreements and navigational charts that would connect distant lands in ways previously unimagined. However, not all mathematical relationships are evident to the naked eye. Here, the beauty of abstract mathematics reveals itself. The development of equations and formulas enabled a deeper understanding of measurement, allowing people to make predictions with a precision that was astonishing for the time. Whether it was calculating distances using the Pythagorean theorem or predicting tides through mathematical modeling, these tools empowered humanity to manipulate the physical world with newfound rigor. The relationship between mathematics and measurement became symbiotic, fostering advances that would lead to major technological shifts. As we delve deeper into this narrative, we see how this intricate dance between mathematics and measurement set the stage for unprecedented innovations. The accomplishments built upon these foundational ideas paved the way for the Industrial Revolution, where machines would further demand precise calculations and measurements for efficient production. This interdependence created a feedback loop that propelled human ingenuity to new heights. As we contemplate the legacy of this merging, we are reminded that it was not merely the rise of mathematics, but the profound understanding it brought to measuring life's complexities, enriching our understanding of the world around us. As the 20th century unfolded, the world found itself on the cusp of a revolution that would redefine not only how we travel, communicate, and understand our universe, but also how we measure it. The advent of the digital age marked a turning point, transforming the ancient practices of measurement into an arena of unprecedented precision and sophistication. In this era, the classical tools and traditional standards gave way to an entirely new mathematical language, enabling humankind to grasp the subtleties of size, distance, and even the very fabric of reality itself. Central to this evolution was the development of computers, which introduced the capability to perform calculations at lightning speed. Imagine trying to measure the vastness of galaxies or the infinitesimal particles of matter through time-consuming manual techniques. With the introduction of digital computing, these once daunting tasks became manageable. Complex algorithms could analyze vast data sets, allowing scientists and engineers to derive precise measurements and model phenomena across multiple disciplines, from physics to biology. The result was a newfound accuracy that transcended any previous reliance on human perception or even mechanical devices. Barcodes, GPS systems, and laser measuring tools are just a few examples underpinning this technological leap. The barcode revolutionized retail, ensuring that an item's price could be precisely scanned and tracked in an instant, thereby streamlining logistics on a massive scale. GPS, a groundbreaking integration of satellite technology, allowed for pinpoint navigation across the globe. No longer confined within the limitations of celestial navigation or rudimentary maps, humanity could traverse continents and oceans with the assurance of digital accuracy. Similarly, laser tools propelled construction and engineering into a new age, providing measurements that were not only accurate but also quick, elevating projects that required exceptional precision, such as skyscrapers or bridges, to unprecedented heights. Yet, this digital transformation has not come without its challenges and complexities. The reliance on technology raises questions about the integrity and authenticity of the measurements we take. Just as the introduction of standardized units once faced criticism for homogenizing diverse cultural practices, today's digital methods often emphasize uniformity at the expense of local contexts. Furthermore, the vast data silos that organizations now maintain can sometimes obscure the very reality they seek to measure. When the tools of measurement become so intricate and embedded in complex algorithms, they risk becoming opaque to the very people who utilize them, raising philosophical ponderings about what it truly means to understand and quantify our world. As we stand at the intersection of human ingenuity and digital technology, we find ourselves armed with not just the power to measure, but to measure better and with greater nuance. The digital age has ushered in a level of precision that was once the stuff of dreams. Yet, with this precision comes a responsibility to navigate a world that can sometimes feel simultaneously limitless and constricted by its own clarifications. The journey of measurement will continue to unfold, inspiring future generations to not only embrace the tools they inherit, but also to dare to question the very frameworks of understanding that those tools construct. As the journey of measurement unfolds toward the horizon of the future, it becomes evident that the tools we have crafted are not merely instruments. They represent the very essence of our understanding and interaction with the world. We stand on the precipice of a new era, where traditional measurement systems are being challenged and redefined by technological advancements and innovative thought processes. The future beckons us to reimagine not just how we quantify our reality, but why we strive to measure at all. In this rapidly evolving landscape, the concept of measurement is transcending its basic arithmetic roots. Think of it as stepping from the realm of rulers and scales into a universe of boundless possibilities, where concepts like time, space, and even human emotions are found to have depths that go beyond mere numerical evaluation. Quantum physics, for instance, poses questions about the very fabric of reality, pushing us to consider measurements in probabilistic terms rather than fixed values. Imagine measuring not just distances or weights, but the likelihood of an event occurring. This scientific shift encourages us to embrace uncertainty as an intrinsic part of understanding the universe. Moreover, as we delve deeper into the realm of artificial intelligence and machine learning, the act of measurement itself begins to harmonize with the intricacies of human experience. Algorithms are now capable of interpreting vast amounts of data, allowing for more nuanced understanding and predictions. Instead of just measuring value through conventional metrics, we can now assess qualitative aspects of our lives like happiness, well-being, or social connectedness through data-driven insights. This rethought perspective opens up new avenues for human advancement, rendering measurement not merely a tool for analysis, but also a lens through which to understand the complexities of our world and our place within it. Yet, this journey into the future also evokes ethical considerations. As our capacity to measure expands, we grapple with questions of privacy, equity, and the consequences of over-reliance on data. The potential for misuse is a sobering reality. Not all metrics carry the same weight, and the implications of certain measurements can disproportionately affect the marginalized. Thus, while we march forward, there is a clarion call for critical reflection, a demand for intentionality in the ways we choose to measure and value the world around us. As we stand at this crossroads, it becomes increasingly apparent that the future of measurement is not a straight path, but a multi-dimensional tapestry woven with both rigor and empathy. The landscapes of measurement are now populated with new dimensions: digital, emotional, social, and ethical. And as we look ahead, we must cultivate a mindset that recognizes measurement as dynamic and holistic. With each step forward, we are reminded that measurement in all its forms is not only about capturing reality, but also about shaping it, challenging us to not just quantify existence, but to enrich it. In this way, the story of measurement continues to unfold, inviting us to explore uncharted territories where numbers and meaning coexist in intricate balance.